Okay, so let us now understand matrix multiplication with the help of suitable examples. We'll start with very simple matrices so that we understand the process, the technique, and then we will go on to higher order matrices. Okay, so let us first take two simple matrices. Okay, let's say A is equal to 1 and 2. It is a row matrix. It has one row and two columns. And let's say another matrix B is given by 5 and minus 2. It is a column matrix. It has two rows and one column. Now, are these two matrices eligible to be multiplied? Let us check that. Here, the number of columns of the first matrix A is equal to 2 and the number of rows of the second matrix is equal to 2. So yes, these two matrices are eligible to be multiplied because the number of columns of the first matrix is equal to the number of rows of the second matrix. So now let us perform the multiplication. So how is this multiplication done? Okay, so AB multiplication. Now the resultant matrix, which is the product, it will have dimension, it will have order 1 cross 1. This is very important. It will have one row and one column. So necessarily it is just one element in that matrix. So let us see how is this matrix multiplication done. See, 1 2 and this is 5 and minus 2. So this row, okay, this row is multiplied with this column. Okay, so how it is multiplied is that, just imagine this two elements, this one it comes here and this 2 it comes here. Okay, now the operation is this one is multiplied with 5, this one is multiplied with 5 and this 2 is multiplied with minus 2 and these two are added. Okay, this one it comes here, this 2 it comes here. Okay, this one is multiplied with 5, this 2 is multiplied with minus 2 and they are added. So the result is 5 plus minus 4, which is equal to 1. This is a 1 cross 1 matrix, one row, one column. Okay, I am using this simple example so that when we will handle higher order matrices, it will be easier for us to understand. See, this one it comes here, this 2 it comes here, they are multiplied with the respective column elements and then they are added. Now let us take a third order row and column matrices. Okay, let us say we have A is equal to 1, 2 and 3 and B is equal to 1, 2, 1. Okay, so this is a row matrix with one row and three columns, and this is a column matrix with 3 rows and 1 column. So these two matrices are eligible to be multiplied. Okay, these two matrices are eligible to be multiplied because the number of columns of the first matrix, that is A, is equal to the number of rows of the second matrix, which is B. So how this operation takes place? Let us see. 1, 2, 3. Let us write it in this way, and this is 1, 2, 1. So what happens? This row is multiplied with this column. Okay, this row is multiplied with this column. This one, it comes here. This one, it comes here. This 2, it comes here. This 3, it comes here. So 1 into 1, 2 into 2, 3 into 1. 1 into 1, 2 into 2, 3 into 1. Okay, 1 into 1, 2 into 2, 3 into 1. And this products, they are added. These product terms, they are added. And we get the result as 1 plus 4 plus 3, okay, which is equal to 8. Okay, the resultant matrix is a 1 cross 1 matrix. Is a 1 cross 1 matrix. Okay.